only 5. You know that okay, the school is collecting your attendance. Okay, so that you need to get aware about that. Okay, anyway, so let me first check the attendance. Yeah. 20, Raymond Kui. 20, Raymond Kui. 20, Raymond Kui. 15, Arlene R. Ghana. 15, Arlene R. Ghana. 15, Arlene R. Ghana. 17, Noor R. Mohammed Birbedikov. 17, Noor R. Mohammed Birbedikov. 17, Noor R. Mohammed Birbedikov. Then let me inform them in the WeChat. Mohammed Syed Dema. 34, Mohammed Syed Dema. 34, Mohammed Syed Dema. 5, Masudu Zaman. Yes, okay. 29, Ibrahim Rob Job. 29, Ibrahim Rob Job. 29, Ibrahim Rob Job. 30, Mohammed Temir Kia.
Yes, Lord Champagne.
Okay. 5, Mikhail M. Safa. 5. Anybody? 5, Mikhail M. Safa. 5, Mikhail M. Safa. 6, Solomon Carleton.
Yes, sir.
Okay. 8, Sador Dadajonov. 8, Sador Dadajonov. 8, Sador Dadajonov. 10, Tamar Marik Daminov. 10, Tamar Marik Daminov. 10, Tamar Marik Daminov. 12, Priest David Gilgaov.
Yes, Lord.
Okay. 14, Hashibu Rahman Noor.
Yes, Lord
Four-
Champagne.
Okay. 15, Mihrab Hossein. 15, Mihrab Hossein. 15, Mihrab Hossein. 21, Janitor Fedas. 21, Janitor Fedas. 21, Janitor Fetus. 22, Abraham K. Kromas. 22, Abraham K. Kromas. 22, Abraham K. Kromas. 25, B. Theophilus G. Russell. 25, B. Theophilus G. Russell. 25, B. Theophilus G. Russell. 29. I'm sorry, 26. Solomon K. Sawyer. 26. Solomon K. Sawyer. 26. Solomon K. Sawyer. 29. Bethlehem Tirahan Mamo.
Yes, 老师, I'm here.
Okay. 30. Next Laiken Asifa. 30. Next Laiken Asifa. 30. Next Laiken Asifa. 31. Valery Batuk. 31. Valery Batuk. 31. Valery Batuk. 32. Anna Akulova. Hmm?
Yes,
Right?
Laoshi.
Oh, yes.
Yes,
Oh, you
Laoshi.
are Anna Akulova, right?
Yes.
Okay.
Laoshi, my ID is 08. Sorry for the late.
Sador Dadajonov? Sador?
Yeah, of course. Yes,
Okay.
thanks.
Laoshi, I have ID number 10. Sorry for
Marik?
being late. Yes, I'm just in the visit center, so it's noisy here.
Okay.
Okay, thanks.
Hello, Laoshi. I'm number 29, Ibrahim. Ibrahim Rob.
29. Ibrahim?
Yeah.
Okay. 33. Levan Takabo River Marine.
Yeah, Laoshi. I'm here.
Okay. 34. Bignar Ikram. 34. Bignar Ikram. 34. Bignar Ikram. 36. Azamat Karimuni. 36. Azamat Karimuni. 36. Azamat Karimuni. You know that your school, okay, ask our teacher okay, to report your attendance situation okay, during the previous several weeks. Okay, so that please come to the class on time, okay? Otherwise, okay, I think that you may have some problem maybe, okay? But I hope that all of you can still have the anyway. So I think that next time, okay, please be on time to join the class. Okay. Anyway, let's firstly have a review about our last lecture. Okay. Okay. So last lecture, okay, we discussed the development in the embedded system. Specifically, we discussed the two embedded software model. The first one is the non-OS. Well, let me share screen. Okay. Yeah, wait a second. Let me share a screen. Okay. Mikhail M. Safa, okay.
Yes, press like
yeah.
let me
Yeah,
press it.
okay. I see. I see you. Okay, can you see the slides? Okay.
Yes, Laoshi.
Okay. So we discussed the two types of the software model in the embedded system. So the one is the non-OS, okay. The other is OS, okay. So the so-called non-OS is actually the application level development, right? So in embedded system environment, okay, so the application level development, okay, means that we need to handle the hardware directly by our program there itself. Okay. That okay, we show an example in the embedded system development. Okay. So generally speaking, okay, the development in the embedded system involves 5 steps. Okay. Because the development in embedded system always involved with embedded hardware. So okay, the first step, okay, understand hardware diagram. Okay. And the second step, okay, driver programming. Okay. So there are 2 steps are different from our from the software development in the conventional computer environment. Okay. Because that in the conventional computer environment, when we develop a software or write some program, we don't have to care too much about the hardware. Since that in most cases, okay, the project or the software, okay, we developed in our computer, okay, it's running environment also, okay, also the computer itself. But here things are different. Okay, we have mentioned that in the development, we in the development in the embedded system environment, we mostly use the so-called host target development. So it means that we develop the software in a computer, but the developed code, okay, need to be run in some embedded device. Okay. So the main difference is that the development environment is different from the running environment, okay, because most of the embedded device do not have the resource to support the program development. Then to develop an embedded software, okay, because we need to use the hardware, so that we first need to understand how the hardware works. So here we need to read and understand the hardware diagram, such as the circuits, how it works. Then the driver programming, okay. So here, the driver, okay, yeah, we know that the driver is the program to operate directly on the hardware, okay. Because we want to manipulate the hardware, so that here we need to write the driver, okay. Here the driver, okay, we write some in more detail. Actually, we extend the existing driver, okay, of the embedded device. Okay. The extend means that okay, we need to provide some function, okay, such as configuration, initialization, and some other operating functions to the application program. Okay. The next 3 steps, okay, are similar to the.
Hello, Laoshi.
Hello.
Laoshi means roll call.
15. Okay, let me see.
Yeah.
Mehrab Hossein, right?
Yes, sir.
Okay.
Thank you, Laoshi.
Next time, please be on time. Okay. So
Yeah, my internet connection is late.
Abraham. Okay, let me see. 22, Abraham. Abraham. Right? Please open your microphone. Abraham. Abraham, 22. Hello? Hello? Anyway, so the next three steps, okay, are similar to the software development, okay, in a conventional computer. Okay, we write the application program and use tools to compile and debug. But actually, there are still some difference because that, okay, the debug, okay, in the debugging step, we can directly debug and run our application, okay, in the development environment when we develop conventional computer software. But here, for the embedded software, okay, because of the host target environment, here debugging, okay, we can only use some simulator, okay, in the development environment. But the simulator sometimes, okay, cannot really reflect the target hardware environment. So still, even your application, okay, your embedded code, okay, application code have passed the simulator, okay, but we still cannot guarantee that your code can run well on the target embedded hardware. Okay, so here is the skeleton of the driver programming here. So that we need to provide the configuration, initialization. Okay, here. So generally speaking, we will need to read the document of the driver, okay, the hardware driver, and use the registers, okay, to do the configuration and initialization. In more detail, actually, we set the corresponding bits of the registers. Same as here happens here of the operating functions, okay, including on and off. Okay. So here in this another example, okay, we use on, and we let the LED on and off. These things all have been done through the setting of certain bits. Okay, but when for the application programming, okay, it's simple that we simply invoke these functions. For the OS model, okay, since a little bit different, okay. So actually, we have a more layer of the encapsulation, and so that the detailed, okay, detailed hardware operating functions and configuration initialization functions, okay, are encapsulated with as a system API, okay, like that. Okay. So for instance, okay, this we can directly use the normal system API like Open LLSCT to invoke the concrete functions here. Okay. So this is different. With this with this layer of the encapsulation, okay, the programming, okay, under the OS model, we can utilize more shared code, and we can those have less maintenance hardness and also have less development cost. Okay, so today let's move on to a new chapter, okay, chapter 2, ARM architecture. So in this chapter, okay, we have two sections. Okay. The first one is the second one is the development within the ARM architecture. Okay. So exactly what is ARM? Okay, ARM. These three words, IARM. Okay, they stands for the advanced RISC machine. Okay. So actually, many beginners in the embedded system, okay, usually associate ARM, the term ARM, with the term embedded. Okay. So because at the ARM, okay, so many embedded processor, okay, use the ARM's architecture. Okay. As we already discussed, that the ARM takes roughly 70% of the global embedded market. So ARM, okay, the ARM company, okay, is an electronic company founded in UK. Okay. It is founded in the 1990s. Okay. So another year, okay, the Apple, the Acron company, and the VLSI technology, these three companies together, okay, founded the ARM company in UK. Okay. Within these three companies, okay, the Acron company, okay, had proposed the first commercial RISC processor, okay, in the world. While at that time, okay, at the 1990s, okay, the Apple, okay, want to apply the RISC processors in Apple products, so that they cooperate with VLSI, okay, technology to founded ARM and produce so that the ARM and generate the ARM standard for the processors. So in ARM, okay, ARM company, okay, it is very successful nowadays. Okay. Why it is so successful? Okay, because it's because of its business model, specifically the chipless production model. So ARM itself does not produce any chip. Okay. Even ARM does not design the entire chip. It simply design the IP cores. Okay. So all around the world, okay, Apple has many partners. Okay. For instance, more than 100 giant IT companies, okay, use ARM technology. While, okay, among the largest 20 largest semiconductor manufacturers, okay, 19 of the 20 are ARM users. So, sorry. So this is the entire chip, right? Okay. So ARM, it only designs the IP core. Okay. The IP core, okay, meaning charges for the instruction fetching, decoding, and executing. Okay. Also, okay, there are some buses, okay, some cache memories, okay, within it. So the Apple and other companies, okay, who is the ARM's partner, okay, they design the they firstly buy the IP cores design, and then they design their own interface module here, and combine them together to create an entire chip. So let's say, okay, this figure, okay, shows the ARM's partners all around the world. Okay, you can take a look at this figure. Okay, there are so many big companies. Okay, you can see many familiar name in it, right? Okay, for instance, Siemens, okay, Microsoft, like the Symbian, okay, many of the famous companies. Okay. Here, let's briefly talk about the history of the ARM company. Okay. So in 1985, okay, Roger Wilson and Steve Ferber, they designed a 32-bit 6 megahertz processor and constructed an ISA computer with it. So, which name is ARM. But here, this ARM refers to Acorn ISA machine. Okay, so here A is still Acorn, not the advanced. Okay, then 1990. Okay, as I just mentioned. Okay, because the Apple want to apply the ISA technology. Okay, in their products. So the ARM company was founded. However, in the 1990s, okay, the ARM processor actually its sales were not that good. Okay, but okay, when the times come to the 21st century, okay, with the development of the mobile phones, okay. So many cell phones are using the ARM processor. So the sales, okay, has shown an explosive growth. Okay. As a result, the ARM processor has occupied the largest share in the global mobile phone market. So ARM's the revenue, okay, meaning comes from two aspects. Okay, the first one, okay, is a patent licensing fee. Okay, it means that, okay, suppose any IC design companies, okay, want to use the design of an ARM IP core, okay, it must firstly pay a one-time licensing fee, okay, so that ARM authorize them to use this IP core. Okay. Well, this is not the only revenue. Okay, another revenue is that, okay, so suppose, okay, one company, okay, have purchased, okay, the licensing of one ARM IP core, okay, and they have designed their own chip based on this version of the Apple's IP core. Then, okay, it's okay, okay. Then you can produce this kind of chips. Okay, at this time, okay, when manufacturing this kind of chip, okay, the ARM will not charge you for any fee. But once this chip has been sold, okay, once this chip has been sold, okay, then for each chip, okay, each chip sold, then you have to pay for each chip sold, you have to pay ARM a certain portion of the patent fee. Okay, so which means that, okay, if you sells a chip that use the ARM's IP core, okay, then the more you sell the chip, okay, then the more the ARM company can get the patent fee. Okay. Generally speaking, these two revenue, okay, accounts for 17% of the total revenue of the ARM company. Okay, so let's take a look at the ARM processor features. Okay, so why ARM processor is so popular? ARM, its processor are meaning MPU. So here we focus on the features of ARM MPU. Remember what is MPU? Anybody can answer this? What is MPU? Anybody can answer this question? Okay, so let me pick up one. 22, Abirahim. Abirahim, are you here?
Which one? Is it 29 or 22?
22, Abirahim. 22, Abirahim.
29, Ibrahim 29.
Abirahim, you are not here? Okay, let me see another one. Okay. 33, Lawan. Okay, microprocessor unit. Yeah, you are right. Yeah, you are right. Microprocessor unit. Okay. Remember that. There are five typical processors in the embedded system. Totally the MCU, MPU, DSP, SoC, and SOPC. But the MPU, which is involved from the CPU, because that nowadays the mobile phone, takes a large percentage of the embedded products. So that we can say that the MPU, is the most popular embedded processor. So here, ARM MPU features. Firstly, it is an RISC. So that with RISC architecture, so means that it's in its instruction set. All the instructions have a certain length, fixed length. Also, its size small and with low power consumption. Also, cost is low, but with comparatively high performance. Most ARM processor supports two instruction set. The low level, the 13 bits, 16 bits instruction set some, and the 32 bits instruction set ARM. But they also has compatible with some low level embedded devices which use the 8-bit and 16 bits instruction set. Because that a lot of the single chip computer, so-called the MCU, they are still use the instruction set with 8 bits, because they have very low price, and have relatively small size, and they do not need too much good performance. So they still use the 8 bits instruction set. As we mentioned before, RISC, when comparing with CISC, its instruction has less capability. So that to mitigate this problem, ARM equips its processor with more registers, so that it can enhance the execution speed of the instructions. And most of the data operations are performed in the registers. So we know that okay, the execution speed, okay, in a computer architecture, okay, we have several levels of the okay storage. So the lowest level is the hardware, okay, then the second lowest one, okay, is the main memory, okay. Then on top of the main memory, okay, it is the cache. Well, at the very top of this hierarchy, it is the register. Okay. So we know that within this storage hierarchy, okay, the execution speed when the execution speed is more faster, but the price, okay, is more expensive. Okay, so the hardware, okay, the hard disk, it has the largest storage, but it has the lowest execution speed. While the register, okay, they have the fastest execution speed, but with the lowest storage. Then the addressing model in the ARM instruction set, okay, it is relatively flexible and simple, and with relatively efficient execution time. Here speaking, okay, to ensure the high performance, okay, the ARM chip, okay, its size and power, its power consumption, okay, size and power consumption are reduced as much as possible. Okay. ARM company, okay, applies some special technology. Firstly, in the data processing instructions, it includes both arithmetic logical processing and shift processing. So, okay, since you have learned the assembly, so you know that the arithmetic logic, okay, and shift. So these two actually can you can say that the arithmetic logic and the shift can construct, okay, almost all the calculation operations, right? Especially because of the, we know that we use the binary, okay, we use the binaries actually in the machine code, so that the shift instruction is very important and should be efficiently implemented, so that that's why the ARM, okay, processor can have a relatively high execution speed, okay, because that they support the directly number shift. Also, ARM use address auto increment. Here, the increment refers to both the increase and the decrease. Okay, so it's auto increment to optimize the loop processing. Okay, so actually, the loop, right? Essentially, yeah, it depends on the counters, right? The counter increase or the counter decrease, then meet a certain condition, okay? Then the loop stops. So here the ARM, okay, use the address auto increment to so the load and store instructions, okay? So the normal load store instructions, they can either load or store, okay, data just in a unit of byte or in the unit of word. But here, the ARM supplies some special load and store instructions so that they can transfer the data, okay, in batches. so that the speed of data transmission, okay, either loading or storing, okay, are greatly increased. Then, okay, whenever an instruction to be executed, it depends on the execution result of the previous instructions, so that to improve the execution efficiency. Generally speaking, the ARM's MPU, okay, it's mainly used in these following areas. Okay. Firstly, the wireless communication. Okay. We know, you know, okay, what is wireless communication, right? Okay. The cell phone, okay, we use every day, okay, is a kind of, okay, wireless communication application, right? I think some of you, okay, are using cell phone, okay, to join the Tencent meeting and watching, okay, this course, right? Okay, so this is the kind of usage of wireless. Then more than 85% of the world's wireless communication devices use ARM processors. And the Bluetooth, okay, the most of the famous Bluetooth manufacturers, okay, like Ericsson, Intel, Lucent, Alcatel, and other companies, okay, they also use the ARM processor. The network, okay, here the network mainly refers to the wired, okay, wired communication. Okay. So most of the ADSL, okay, chipsets, okay, use ARM processor. While the consumer electronics, okay, the ARM is widely used in the digital audio field, digital set-top box, and the game console. The applications, the many digital cameras and printers, okay, and also some driving device, safety entertainment devices, okay, they are all use ARM processor. Then here, let me introduce some series of ARM MPU. Okay. Firstly, the ARM9. Okay. ARM9, okay, they use the ARM9 TDMI core. So what does the term TDMI stand for? Okay. Here, the T means that it can support the 16-bit thumb instruction set. Okay. Then the D means that it supports the on-chip debugging. The M means that this processor, okay, equips with embedded hardware multiplier. You know that the multiple, okay, you can, okay, implement the multiple by adding many times, right? But here, with the hardware implementation, okay, it can increase the execution speed for the multiplication. Okay. Then I, okay, I means it has an embedded ICE, which also supports the other on-chip debugging. So the main type of the ARM9 series, including, okay, the ARM 920T, ARM 922T, and the ARM 940T. So the ARM9, okay, of course, it is a kind of ISA processor. Okay, actually, almost all the ARM, okay, processors, they are ISA. Okay, and supports the two instruction set. Okay, 32-bit instruction set and 16-bit instruction set. Well, please be aware about that here. Since ARM9, okay, it uses the instruction execution pipeline. While in the ARM9 processor, okay, it equips with a 5-stage pipeline. So here we will discuss it later. Okay. Then the bus in the ARM9 processor, it is a 32-bit MBA bus. And it supports MMU. Okay. You know MMU, right? Anybody know what is MMU? No? Nobody knows what is MMU? So MMU, okay, is memory management unit. I think that in your operating system course, right, you should have learned some memory mapping or the memory, Abraham, you are right. Yeah, memory management unit, right. Because that when you learn the operating system class, you should have learned some memory mapping and memory scheduling algorithm that and your teacher should tell you that okay, it is the task of the MMU. Okay. It can support the MMU, okay, and so that it can support the running of the WinCE and the embedded Linux and other types of embedded operating systems. Also, it has a unified data cache and the instruction cache. Okay. So we know that the cache, okay, is a very important intermediate between the which is set between the register and the main memory. Okay. It's the execution time of the execution speed of the cache. Okay, is between the register and the main memory. Okay. Generally speaking, depends on the type of the ARM9 processor. Okay, it has 3 different manufacturing technology. Okay, since the 0.18 μm, you know μm, right? Okay, it is 1 million μm. Okay, equals to 1 meter. Okay, the 0.15 μm and 0.13 μm. Okay. ARM9 also support the RTOS, okay, real-time OS like the VxWorks. So here, okay, we just mentioned that the ARM9 okay, applies the 5-stage pipeline for instruction. But let's say, okay, what is the 5 stages? So firstly, the instruction fetching. So the processor, okay, will read the next expected instruction to be executed into the buffer. Okay. Then instruction decoding. So in this step, the processor will determine okay, the OP code and the operands specifiers. So it needs to calculate the operands. Okay. Specifically, it needs to occupy the effective address of each operand. Then need to fetch the operands. Okay. So because that you know that some operands, okay, it is stored indirectly. So it means that okay, the operands itself okay, just a memory address. So we need to get the real operands from that address. Okay. So that we need to firstly calculate it and then fetch the real operands. Of course, some operands are simply registers or simply intermediate variables. okay, then intermediate variable so that we can relatively directly get it. Okay. Then after instruction fetching and instruction decoding, okay, then it's time to execute the instruction. Also, okay, during the execution of the instruction, okay, we may still need to do some memory access, okay. As a load, we may read something, okay, from memory, or we may write, okay, maybe write the calculation result, or write some or output something, okay. Anyway, we need to do some memory accessing. Finally, we write back, okay, store the result. So this figure roughly demonstrate the 5-stage pipeline. Okay, so you can see that, okay, this is the first instruction. Okay, they have this 5 stages. Okay, it is executed, okay, in the in these 5 stages one by one. Okay, but when it is comes to the second stage, then the second instruction, okay, as the first stage, the instruction fetching, then we can do it. Okay, while okay, when the times come to the third stage of the first instruction, okay, when it is executing the instruction, then the third instruction, okay, comes to execute its instruction fetching. Okay. So in general speaking, for the 5-stage pipeline, okay, so we actually have 5, okay, components in the processor that can handle instruction fetching, instruction decoding, execution, memory accessing, and write back. These 5 stages, okay, so that okay, once the one instruction have finished one of the states, such as the instruction fetching, then then it comes to the next stage. So at this time, okay, the components not charged for the instruction fetching, okay, now it's idle, so it can handle the another instruction fetching stage. So that at the ideal case that we can have 5 instructions to be handled at the same time. Okay, so at this time you can see that okay, the first instruction, okay, it is on the write back stage. Okay, then the second instruction, it is on the memory access stage, while the third instruction, okay, is on the execute stage, while the fourth instruction is on the instruction decoding stage, and the fifth instruction is on the instruction fetching stage. So okay, the 5 instructions are actually being processed by the processor at the same time. Okay. So potentially, okay, we can get 5 times the performance of a single stage processor. Okay. So which means that if a processor can only execute this stage and handle the instruction, okay, one by one, okay, then such 5-stage pipeline, okay, can have okay 5 times of the performance. So with the multi-stage pipeline architecture, okay, it has many advantages. Okay, so firstly, with the multi-stage pipeline, okay, we can have much better instruction throughput. Then, okay, if we want to enhance the performance, we can simply divided the instruction into more stage. Okay, before we just discussed the 5 the 5-stage pipeline. Okay, so if we divide the instruction to 6 stage, to 7 stage, or to 8 stage, right? Okay, then we can have more instruction to be executed simultaneously, right? Okay, then we can have 6 or 7 or 8 times performance. Okay, then with the pipeline architecture, the faster LRU, arithmetic logic unit, which is hardware to handle the arithmetic logic operation. The fast LRU can be designed when the pipeline architecture is used. Then the pipeline processors works at a higher clock frequency than the RAM. Also, the pipeline increases the overall performance of the processor. But it also has some disadvantages. So firstly, of course, with the multi-stage pipeline architecture, the processor becomes more and more complex. With the number of the stages, stages increase. Also, the instruction latency increase in the pipeline processor, because after it is divided into so many stages. But the entire for a single instruction, its latency may increase, but for the entire execution of the program, its execution speed are increased. While the through output of a pipeline processor is difficult to predict, because that although it is the most ideal case, for instance, the 5-stage pipeline architecture may have 5 times performance than a normal processor, but it is the ideal case. While the longer pipeline, the worse the problem of the hazard of a branch instruction. This is a problem of the pipeline architecture, the so-called pipeline hazard. So what is the pipeline hazard? So in a typical computer program, they should have branch instructions, interrupt operations, read, write, instructions, and so on. However, a pipeline are not suitable for all kinds of instructions. When sometimes instructions are executed in pipeline, they can store the pipeline or flash it totally. This type of problems caused during pipeline is called the pipeline hazards. So how does it comes? So exactly why? So let's take let's show a simple example. So suppose in your program, the result from the instruction number 1 is used as an operand by the instruction 2. I think this one is very simple, right? You use some statement, for instance, like a variable a, a is assigned with a certain value, for instance, a assigned with certain inputs or from outside. Then after some other statement, then there is a statement need to use the result of the variable A. So when such instructions are executed in pipeline, then the breakdown will happen. If the first execution the first instruction have not been executed fully, so that if the variable A its calculation haven't been done, and its value have not been read back to the memory, then the second instruction, either its operands, which is the variable A, then it cannot continue to run, right? Then the second instruction have to wait until the first instruction to finish. So this is the so-called pipeline hazard, and this is a very simple case. Some complex example involves some address modeling, and also may involve some if the instruction needed to use some hardware, some I/O, or some memory, They also, generally speaking, if the instructions have some you can imagine that it's something like the resource allocation problem. It's something like somehow like the deadlock. Then it possibly the pipeline hazards. Okay. Let's say the ARM9E. So this one it uses a single processor core provides the solution of microcontroller, DSP, and Java application system. So it reduces the size of the whole chip, and the power consumption. Also, it shortens the development cycle of the products. So here, the 9E, what is the E means? So E means that this kind of processor can support the DSP. DSP is a processor that specifically for the high-speed digital signal processing. Well, J means that it supports Java. S means that it is an integrable version. So here means that multi-processor cores can be used together in a single chip. Actually, nowadays, most of the chips, in our cell phone, are two cores, right? 4 cores, 8 cores, or even more cores, right? So this is at the S processor. Well, the DSP, the high speed digital signal processing. You know that the mobile phone, we have many functionalities. We use the mobile phones to watch videos and to listen music, to talk with other guys. All these things need the support of the DSP. Well, Java, remember, the Android system, Android system, is built upon what? I have mentioned in the the third lecture, right? In the bottom of the Android system, it is the Linux, but actually the Android application is built upon what? Anybody remembers? No. So, no, what here Android OS its bottom layer okay, is the Linux, okay, but the Linux, okay, you know, based on the Linux, the Android system also build a Java virtual machine. Then the Android application are running within the Java virtual machine. So actually, many Java application, yeah, JVM, right? The one you memorize it, okay? JVM, okay. Actually, many Java application, okay, are written in the Java language. Okay. So here you see J, okay. J means that it supports Java. So how to support Java, right? We know that the Java program have to run, okay, in the JVM. Okay. So that's why, okay, you know that the most more than 80% of the cell phone, okay, are using the using the Android system, right? Okay, and the more than 70% of the cell phone, okay, are using the ARM processor, okay. They have the ring shape, okay, because that the ARM processor support the Java and the JVM, okay, so that they can support the Android OS. Also, okay, ARM 9E support the WebP9 floating point processing coprocessor, okay. Okay, so you know, do you know what is the floating point processing or the floating point calculation? When you learn the programming language, so the variable type, okay, so you should know that there are some type called the float, right? No? Float type, yeah, the data type, right? The float type. So actually, the float point, yeah, the float type and the float point processing, okay. This one means that it supports such float point processing means that it can support more complex arithmetic calculation in more details, okay. It can support some kinds of the scientific calculation. Because that in some simple calculation, okay, we just use the normal calculating and processing is okay. Okay, but when the case comes to the scientific calculation, okay, we need the floating point process. Well, it also has a very good execution speed. Okay, it can up to 300 MIPS. Okay, so here means that it can calculate 300 meaning instructions per second. So here this M refers to meaning, I means instruction, P means per, S means second. Okay, the meaning instructions per second. Let's see the ARM 10E. So comparatively, the ARM 10E, okay, is a new architecture. and it has a new mode named the Energy7. Okay. You know that the saving energy, okay, is mentioned by many places. Okay. Also, okay, in since ARM 10, okay, it can support the 64-bit I/O. It also have a floating point coprocessor. More specifically, okay, it can support vector operation. Okay, you know, vector operation refers to some matrix, okay, calculation, right? Matrix, one matrix consists of several vectors, right? Okay. So it can support the matrix calculation. The floating point coprocessor, okay, it follows the IEEE 754 standard. Also, it can have the convenient system integration. The classic type of the ARM10E series, including the ARM10 20E, ARM10 22E, and ARM10 26 EGS. Okay, so let's see the features of the ARM10E series. Okay. So here, the so-called ARM9, ARM10, and ARM9E and ARM10E, okay, they all refers to a series of ARM processor, okay, not just refer to one single ARM processor, okay. So ARM10E, okay, it also support the DSP, okay, so it is suitable for high-speed digital signal processing. Then, okay, it equips with a 6-stage pipeline. Remember that the ARM9, okay, its pipeline is 5-stage. Okay, so comparatively, the 6-stage pipeline can have 6 times performance of the processor with no pipeline. It also supports these two instruction set, okay, 32-bit ARM and 16-bit SUM. It also uses the MPA, okay, bus. While the floating coprocessor, it is the VIP10. Also, it has a full performance MMU and supports the Windows CE, embedded Linux, Palm OS. It supports data cache and instruction cache, and with higher instruction and data processing capabilities. Then its speed has increased to 400 MIPS. Let's see some the ARM9, ARM10, okay, are some common purpose processor, okay. But here, the Secure Core series processors, okay, they are designed specifically for security purpose. So let's see, okay. Firstly, it provides the security solution for the 32-bit ISA. Its typical type is including the LC100, LC110, LC200, and LC250. 210. So where are the security code serial processors are used? Okay. There are many used in the products that with high security requirements, including e-commercial products, e-government products, e-banking, network, and authentication systems. So the secure core serial processors, okay, they have a flexible protection unit to ensure the security of operating system and application data. Specifically, okay, they can prevent external scanning and detection. Yeah, you are the student of the computer technology, okay? So that yeah, but you may not have learned something about the information security. Okay, so you know that any attack, okay, any attack against a computer system, okay, always starts with some scouting, like the port scan and other kinds of detection technologies. Okay. So here, to prevent such attacks, that we need to protect our system from the external scouting. If the internal information of our system cannot be obtained by the attackers, then we can claim that the system is safe. So here, the secure core serial processors can prevent such external scouting. Also, okay, it can extend its security functionalities. Okay, so the users can write their own security policies and features. Also, if the user want to use some other security core processor, it's okay. Okay, they can work together. Then the X scale. Okay. This series is based on the ARM v5T architecture. Okay. It has relatively high cost effectiveness, but with a low power consumption. Comparatively, okay, it can support just the 16-bit sum instruction. Okay. Please be aware about that. It supports the 16-bit instruction set only, okay. But it also supports DSP. So it has been applied to the products like the mobile phone, PDA, and networks, and some network products. So the XCell, okay, is manufactured by the Intel. Some classical types of the X-scale processors, including the PSA 25X, PXA 26X, and the PXA 27X. So actually, you know that Intel, right? Okay, Intel processors. Okay, it is the first processor. Okay, in the Pentium processor. The Pentium processor is the first computer processor that equips with the instruction execution pipeline. Okay. So, okay, since the X-scale processor are manufactured by Intel, okay, so they also equipped with the pipeline. Okay. The pipeline, okay, is 7 or 8 stages. Okay. Therefore, okay, they can have higher performance. Also, okay, the Intel's media processing technologies okay, is equipped to the processor, so they can effectively handle the multimedia instructions. Then for the addressing, okay, Intel have some optimization in the series of processors. Okay, so in the processor, Intel equipped the ARM core, okay, with 128 address caches for the jump instruction. So that with so many destination address caches, okay, the instruction prefetching and the instruction pipeline can be more efficient. Then it has 32 kilobyte data cache and instruction cache. While the processor, okay, equips with the debugging functionality, okay, so it can have 256 breakpoints at the most. While the memory data-wise is relatively wide, okay, it is 64-bit. So that the data stream can be up to 4.8 gigabytes per second. Then the strong series. Okay. So this series of processors, okay, it integrates the design and processing technologies of Intel and also the power efficiency of the ARM architecture. Okay. Then they adopt the software compatibility, okay, with the ARM v4 architecture and also absorbs the technical advantages of Intel technology. So the strong ARM series, okay, is an ideal choice, okay, for portable communication products. Okay. The portable communication products, okay, actually meaning refers to the mobile phones, okay, for the portable. Also, okay, it can be applied to consumer electronic products. Then the ARM11. So the ARM11, okay, is the first generation, okay, of in the ARM processor. Okay, it uses the ARM v6 instruction architecture. So the processor, okay, use the ARM11 core, okay, have higher performance, especially when it handling the multimedia processing instructions. The classical types of the ARM11 processors, including the ARM11 36J, ARM11 56 and T2, and ARM11 76JZ. So the manufacturing technique for the ARM11 processor is 0.13 μm. Okay. And with the development of the semiconductor manufacturing technology, okay, so the ARM11 have relatively less power consumption. For instance, at the 1.2 okay, voltage, the power consumption of the ARM11 processor, okay, can be as low as 0.4 okay, m-watt per m-hertz. Okay. Then the area, okay, so here we do not count the cache, okay. The area of the chip, okay, is less than 2.7 okay, the ARM11 processors also bring many inconvenience to the ARM developers. So about the ARM developer, we will discuss it in our next lecture. So in this lecture, we mainly introduce the ARM processors. So it may be a little bit tedious. So firstly, ARM11 processor, it contains more multimedia processing instructions. Because that, for the apps, in our cell phone, many of them need to handle the video, and audio, So to speed up the execution of such applications, so the ARM11 processor, it provides more multimedia processing instructions. Also, it has a better memory system, so that can enhance the performance of the operating system. So here the operating system meaning refers to the Android. While the new instructions are provided to accelerate the real-time performance and interrupt response. Then, from the beginning of the design, the ARM11 processor focus on the easier data sharing with other processors and the software migration from non-ARM processors. So it has has a better compatibility. So with other non-ARM processors and non-ARM architecture software. So the ARM11 series processors has already been applied to many places. For instance, the consumer electronics, wireless devices, network applications, and automotive electronics. So here refers to the vehicle devices, car devices. Then the media processing. We mentioned that the ARM11 have better media processing ability, but with low power consumption. So make the ARM11 processor it is better to be used in the wireless and consumer electronic products. Also, the combination of high data through output and high performance makes the ARM11 processor very suitable for network processing applications. While the ARM11 processor it supports the real-time performance and the floating point calculation. With them, the ARM11 can meet the need of the automotive electronic applications. So for instance, the guidance system in our vehicle, they need both the real-time performance and also the floating point calculation. It needs to receive the data from the internet and calculate the current situation on the road. In general speaking, let's make a summary of today's lecture. So the ARM, ARM is a company, famous but small, because that they do not produce the chip by itself. Then, generally speaking, the ARM processor is efficient and simple. Then it takes the largest market share of the mobile phone processor. In general speaking, we can say that from the technology view, okay, the ARM is processor may do not equipped with the best technology, best processor technology, but it still has very good success on commercial because of its commercial model. Okay, today we stop here. See you next time.
OK， 拜，老师，再见。
Bye.
哎，老师，see you。
See you.
OK，老师，goodbye。
Bye bye.
Bye bye。